This is example 8.2 from Discovering Design with Chemistry, and I'm mostly doing it for the final problem or question because the first two I think you could follow through with the book, but we'll go through them anyways. The first question asks if C8H12O4 is an empirical or molecular formula. And because the three numbers at the bottom, the 8, the 12, and the 4, all could be divided by 4, we know that it is a molecular formula because empirical formulas are like the ones that are completely simplified down to the ratios and not the amount of each thing that are used. So this one is molecular. The next one asks, what is the empirical formula of that one? So, the second question kind of gives it away. The first question, that is. But if you notice, all three of these numbers are divisible by 4. So if we take them and we just divide by 4, just like you would when you're simplifying fractions, then we have the empirical formula. If you didn't notice they were divisible by 4 and you divided it by 2, you would have noticed that they again were all even numbers and that you could again divide them by 2 to get it all the way down to the empirical formula. Okay, the last one gives you the empirical formula for a compound, CH5N. Well, okay, that's the empirical formula, but it wants to know what its molecular formula is. And they give us its molar mass. So let's begin with the mass of that particular one. So let's, just like when we're trying to calculate these conversion relationships, let's find the mass in AMU. So we have our periodic table over here to the side. So I'm going to slide a little bit so I can get to the numbers that I need. So here are the C and the N, and here's our H. So we're going to add 12.01 plus 5, 1.01 plus 14.01. So we're going to add those three numbers together, and that will give us our molecular mass. Calculator. Okay. Right. 12.1 plus 5 times, probably should have just typed in 5.05 to make that faster. Okay, so we have 31.07. 31.07 AMU. Okay, so we know that, and it could be the empirical formula is the molecular mass. So getting the molar mass of the empirical formula gets us in the right direction. So the molar mass of this means that the number of grams it takes to make a mole is 31.07. But that's not the molar mass that we were looking for. They told us that the molar mass was 93.21 grams, which means that the molar mass is bigger than what we have. So we know that each of these atoms actually has more, some multiple more. So what we do is we start with the mass that they gave us. This is the true molar mass, 93.21 grams. If we had had the right number here and here and here, and we multiplied each of those numbers here and here and in front of these, and then added them up, we would have gotten 93.21. But because we got 37.07, we know that we got some simplified version. So we're going to divide by this and figure out what is the ratio. In fact, I might set it up a different way in a second just to show you. All right, so let's go ahead and divide this and see, because this 37.01 AMU, if that had CH5N had been the true molecular formula, then this number that we got would have been how many grams per mole, or in other words, the molar mass. But because we didn't get the same number that they gave us for molar mass, we need to figure out what the ratio is. How much did they divide all the numbers by? For example, in our first one, we divided everything by 4 to get what we needed to have the empirical formula. Somebody took this blah, 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 this compound, and they divided everything by something to get CH5N. So we need to figure out what they divided by. So that's why we're dividing these numbers. All right, so the number that we get is 3, which means that's the number that everything was divided by to get the empirical formula. So if we multiply everything back up by 3, we'll get the molecular formula. So C has a 1, so now it has a 3. H has a 5 times 3, that makes 15. And then N also has a 1, so now it's going to have a 3. So that is its molecular formula, is C3H15N3.